Okay, let's go ahead and get started. I'd like to thank everyone who's joining us. Welcome to today's CNCF webinar, Event-Driven Cloud-Native Workflows, Use Cases, and Patterns. I'm Julius Rosenthal. I'll be moderating today's webinar. We would like to thank our presenter, Sebastian Gozagin, CTO at TriggerMesh. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Feel free to drop your questions in there and we'll get to as many as we can before the end of the presentation. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of this Code of Conduct. Basically, please be respectful of your fellow participants and presenters. We'll have a recording and slides up later today on the CNCF webinar page. So with that, I'll hand it over to Sebastian to kick off today's presentation.
All right, thank you very much. No, wrong button, not share, but present. All right, you should see my slides full screen. You should be hearing me loud and clear. If not, I think you have a way to complain and then I trust that somebody will stop me and say, hey, Sebastian, they cannot hear you. But if nobody stops me, then we're gonna get going. I'm very excited to talk to you today. Indeed, my name is Sebastian Gozagin. I'm the co-founder and chief product officer of TriggerMesh. I've been doing Kubernetes and cloud native almost since the beginning. I'm quite happy actually to have started using Kubernetes pre-GA. So it was almost summer 2014. I think I started, it was V1 Beta 2. So it was even before Beta 3 and before GA. So it's been quite a while. And before doing TriggerMesh, you know, I did other things. I'm going to cover that shortly. But today we're going to talk about event-driven cloud-native workflow. I'm going to talk about a few use cases, but also discuss, you know, patterns and technologies that we have at our disposal to do this, right? To do event-driven application, event-driven automation workflows in a cloud-native era. All right. So far so good. Nobody complained. So it looks like, you know, I guess you can hear me loud and clear. And let's get going. So you don't see me, I don't see you. You know, you're gonna hear my beautiful French accent for 40 minutes. Then we're gonna have a little Q&A. But you see a picture of myself, a couple years younger, but that's me right there, no hair. 46, that's what happens. You can follow me on Twitter at SebGoa. And then as I mentioned, I've been doing Kubernetes for a while. Created Skipbox, which was acquired by Bitnami. And then, you know, I developed projects in the Kubernetes ecosystem like Compose with a K, which has been given to the Kubernetes incubator, Kubeless, which is still out there, but not in CNCF or in the incubator, but you know, as a standalone project. We did Cabin, C-A-B-I-N, which was, you know, the first mobile application for Kubernetes. I removed it from the Play Store and the, you know, the App Store because it was tough to maintain without a business model. Before that, I used to be VP of Apache Cloud Stack. So I have a long history, I mean, a relatively long history of open source and developing software. So it's been quite a ride. And these days, you know, indeed, I work on cloud native integration, which we also called event-driven automation workflows. And I created TriggerMesh, right, with my co-founder, Mark Hinkle. So just a tiny background on TriggerMesh before we get started. I promise this is not a sales pitch. But, you know, as I worked on Kubernetes, I really saw it as a platform to build distributed systems, right? Of course, you can deploy your applications if you containerize them. But with especially with the availability of CRDs, custom resource definitions, which used to be called third-party resources, TPRs, we have the ability to customize Kubernetes and to take advantage of, the API server, to take advantage of the patterns that have been shared with us, like, those reconciliation loops and so on. So we can really leverage Kubernetes as a platform to build additional systems, all right? And, we've seen different systems grow over the last few years. But there was particularly one area that, that I tackled, which was the area of function as a service, FaaS. And I did this primarily with Kubeless because we had a lot of people talking about skipping containers and going directly to a serverless era, right? And that was definitely, pushed by AWS and available through all the AWS services. But then, looking at this push towards serverless, the question became, hey, couldn't we do serverless application with Kubernetes, which is this amazing platform to build systems? So I tackled Kubeless and I said, yes, of course, we can build a function as a service solution on top of Kubernetes. It's actually made for that, right? So let's write a function system on top of Kubernetes. Let's take advantage of custom resource definition and let's build a new system, right? And, I'll talk about other systems that were also created roughly at the same time, those, other FaaS systems. But one thing that became clear is that the future of cloud native application was going to go even further, right? It's not just functions, all right? And what we believe at TriggerMesh is that the future of cloud native application is a mesh of functions, but cloud services, and also services coming from on-premises applications, and that all of this is linked by events. All right, so we believe that events are almost going to become the HTTP of future cloud native applications. All right, so that's really the vision that we have here. And the high level reasoning also behind this is that if you adopt this type of architecture for your future applications, you take advantage of best of breed services and you can go much faster. You can deliver value to your business much faster, right? So that's really what we believe. And when you think about this concept of meshing functions and cloud services, whether they are in public clouds, whether they are on-prem, what are you facing with or faced with? You're faced with an integration issue, right? So we see really the problem or the challenge of building these new applications, these new cloud native applications, as an integration problem of, you're starting to use Twilio for, SMS and phone and even, email through SendGrid. You're also using some AWS services, but you have VMware on-prem and maybe you adopted VMware, vSphere 7, so that's where you get your Kubernetes from. Right? And then, of course, you have some Salesforce in your data center or in your organization and some ServiceNow. So you're faced with this integration challenge. And since you're bought into cloud native, of course, you need to do your integrations a cloud native way, right? And what solutions do you have right now? Well, you don't have any because the other integration solutions are not built in the cloud native era. So that's really what we tackle at TriggerMesh, and we believe that this is the future of serverless applications and more generally cloud native applications. All right. So I said this is not a sales speech. So of course we do open source. Mark and I are big open source believer. Mark used to work at CNCF, and we've been long time participants in Apache, at least in our cloud stack days. These days we contribute a lot to Knative. We're a small player, but we are also quite high in the contributor ranks here in Knative. Sadly, of course, Knative is not in CNCF, but that's that's a discussion for another webinar. We have lots of open source assets like our Knative Lambda runtime, our AWS event sources that are quite popular with people who consume AWS services. Action, which is a clone of GitHub Action. So we definitely have a lot of open source assets out there, for you to consume, right? All right, I hope that makes sense. And as always in those webinars, it's a bit difficult because we don't get, the direct feedback here. But that was just, to introduce myself and then, present the company and what we're tackling and how it fits within CNCF. All right. So what I would like to do now is, talk about three things. First, quick introduction about serverless, kind of a recap, and then talk about patterns. Right? What are we seeing out there? What type of, application pattern are we seeing and are available? And then talk about actual tech that we can use, open source tech that we can use to actually implement those patterns. And specifically, I'll talk about Argo, which is CNCF project, but I also talk about, Knative, and I hope nobody will slap me for it, but it's interesting to look at both systems, which, run on Kubernetes. All right. So 3 parts, and, then we'll be going for the Q&A. So let's talk about serverless, right? And serverless 101 or even serverless 001, right? And I've shown this picture for last few years almost, right? Because serverless, like a lot of things, even cloud, it's been difficult to explain and frame because it means different things to different people. But there is this picture that says, hey, there is no serverless. It's just someone else's fully managed execution environment that I only pay a fraction of a cent for whenever my function is run, right? So of course, there is a server, all right? You're running a process. That process is running somewhere. So somewhere there is a server, right? But it's just not your server. It's not your execution environment. You're not managing it. You did not even provision it, okay? The magic of serverless is that the entire infrastructure is hidden from you, okay? That's really, what it means. No servers, right? So you don't take care of the infrastructure. And, of course, there was this, debate between folks doing Kubernetes, style work and then people embracing serverless very early on, because how could you do serverless on-premise and how could you do serverless in Kubernetes? It doesn't make sense because you're still dealing with the infrastructure. You're still dealing, with your own servers, right? And there I always say, the answer is really a question of persona, right? Your developers within your organization, if you give them the right APIs, the right abstractions, you shield them from the infrastructure. So they have a serverless experience. But you have another group in your organization that needs to manage that infrastructure, needs to manage those servers. And definitely for them, it's not serverless, right? And it's exactly the same thing that, if you talk to AWS admins or Google SREs, they're dealing with the servers, they're dealing with the infrastructure. So it's really a question of persona. And some of us, argue that a better term than serverless would have been serviceful. Because when you think really about the applications that you're building with this, and the, the mindset that you have is that you don't want to know the infrastructure. You don't really want to know how it happens, how it scales, how it's even upgraded and things like this. You just want a service. You want a service for machine learning. You want a service for archive. You want a service for translation, right? That's what you want. You're looking for an SDK that helps you build your entire application, except that this application is multi-cloud, distributed, scales automatically, secure, and so on, right? So your world is actually serviceful compared to serverless. So, some of you may think that's kind of a pretty, little tagline and so on. I remember first hearing this term at Ghent in Belgium at DevOps days, and it was used by Patrick Debois, the father of the DevOps movement, and he was working on a startup doing a lot of video, analysis, compression, things like this. And he talked about his challenge about using the cloud, his challenge of developing cloud natively, right? And his challenge was that his world was now serviceful, all right? So it could have been a better term rather than serverless. And of course, AWS is the poster child, of serverless. And I'm not at all criticizing other potential vendor and projects and so on, but it's just a reality. AWS Lambda is the poster child of serverless. It's already 4 years old, maybe 2016, even before, might be 2015, right? So Lambda is already 4 to 5 years old. And what do you do with Lambda? Well, it's a better experience for developers. They just upload their code, and then they can say, hey, my code needs to react when such and such event happens. And then, I only pay for when my function is executed. So it's a very fine-grained billing method, and it's a better, well, some people would say better interface or development workflow for developers, right? That's Lambda. And if we flash back 2016 when I started developing Kubeless, I was a little bit annoyed. Some of us in tech tend to get frustrated at times by other technologies, right? So I was a little bit annoyed that people were saying, oh, we need to move to Lambda and forget about containers, when we were barely getting to production with Kubernetes and containers. So I developed Kubeless as a proof of concept that we could create a Lambda-like experience for developers on top of Kubernetes, right? That's really how it started. And other people, thought about this as well, right? So with this function, mindset, with Lambda, what did people, start to do? So if you go to the AWS website, this is not my picture, okay? I should have put like a, little reference. If you go to the AWS website and you check their use cases, the type of application that you see are, hey, let's put pictures or files in S3 buckets. And as soon as it gets in the bucket, you execute the Lambda, it resizes, creates a thumbnail, whatnot, okay? So a small data pipeline, a small data processing pipeline, which has the huge advantage that S3 is massively scalable, right? Reliable like crazy. I don't know how many nines you have with S3, but it's huge. And then Lambda can also scale, a lot. So it seems like a super simple, processing, just generating thumbnail of pictures. But by using cloud services, by developing this pipeline directly in the cloud, you benefit from a lot of, scale, provided by the cloud provider. Other types of application, a lot of sensors. So IoT is a big use case, lots of sensors sending data to Kinesis streams, and then Lambda being triggered on those streams when there is an event, right? And then you can, create some, some reporting on how your fields are doing or how your cultures are doing, or, trigger orders of fertilizers or whatnot. May not be the perfect example here, but anyway. So the bottom line is that as soon as you're starting doing serverless or Servicefull, what are you doing? Well, you're going a little bit up the stack and you're knitting, if you like, Shaun the Sheep, or you're building Legos, right? You're taking a service here, a service there, you're taking, blue or white, whatever, and then you start knitting your application, you start building your application. And at TriggerMesh, we like to say we are meshing the application, together. We say mesh not in the service mesh sense of the word or world, but really a mesh in the sense of knitting, right? That's really what we do, right? Or if you prefer Legos, well, we're building apps by using pre-existing, bricks, right? So you pick. And as you're doing this, as you're building those cloud native applications, you have a few concepts that emerge from serverless. You have, of course, the concept of functions, right? But serverless is not just functions. A lot of people reduce serverless as functions, but the function bit is actually quite boring. It's actually quite easy. You take some code, you inject it into a container, you need to accelerate the build pipeline and then deploy it. You put some scale to 0 because you don't want to use it too much, right? And then you have functions. And like I say, it's CGI on steroids, and we've been doing this for 20, 40 years. So functions is not that exciting when you think about it. The most exciting part of function is really the developer aspect of things. But then you have other concepts within serverless as you start meshing all those services together. You have a concept of trigger. Okay, what triggers the execution of your code, right? Of course, you have a concept of services, so your machine learning, your translation API, your reporting, and so on. And then you have events, right? Because what we end up with when we build those applications is that they are very loosely coupled. All the services are independent from each other, right? And when they do something, they emit an event. And the system, right, the functions or other services, they react when those events happen, right? And those reactions are coded within the triggers. So that's what you end up with when you're talking about serverless applications. You have definitely the concept of functions, but more importantly, the concept of triggers, services, and events, flowing through the system. All right? At least that's our vision. Okay? So now, let's say you want to do it in open source. How do you do this? How do you, how do you build that type of application? How do you embrace that type of architectures without, just consuming AWS, right? Well, you have systems like Knative, which gives you, a function component with scale to 0. If you don't like Knative, you could go Apache OpenWhisk, even though since the Red Hat IBM acquisition, Red Hat folks are actually retrofitting Apache OpenWhisk with Knative. Oracle has FN project, far right on the side. That's on the slide. That's the Open FaaS logo, right? Which is very good with functions. Within CNCF, you have Argo. So Argo doesn't do functions, but it does events, right? And it also does workflow, and it does, CI/CD. So Argo is an interesting use case within CNCF because it's not just one project. Argo is an umbrella, and there are, 4 projects, right? And then within CNCF, the serverless working group came up with the cloud event spec, right? So it's a specification to describe the shape of an event. And the hope is that the entire industry adopts this spec so that we can all interoperate. What does that mean? It means that if SQS emits an event or Kinesis emits an event and it follows the cloud event spec, within TriggerMesh, we can consume that and then send it to Google Cloud Run, assuming, Cloud Run takes cloud events, right? So that's the cloud event spec. Those are the the tools or weapons that you have in your arsenal. If you think it's a battle, but those are the techs that we have. And of course, at TriggerMesh, we use some of those tools. So we use a lot of Knative. We use a lot of cloud events. We interoperate with Argo events, And we even use a little bit of open FaaS, which has, you know, pre-baked functions. All right. So that was Serverless 101. I'm watching the clock because, of course, I tend to talk a lot, right? Serverless 101. Hope that makes sense. So now patterns, right? So patterns, you know, the best resource I can give you for patterns is actually this paper by Jeremy Daly, who writes the Off by None newsletter. It's a little bit AWS heavy or focused, but it's a great newsletter for, you know, people interested in serverless. And Jeremy wrote this this article called Serverless Microservices Patterns for AWS, right? But again, you know, AWS is actually ahead of the curve here, so we can learn a lot by you know, by looking at this and trying to see, you know, how that can be adapted or adopted within an open source, you know, type environment. So let's review a few of those patterns. The first one, and the one where the one that generated a lot of adoption of Lambda, is the web service pattern, right? So what's the web service pattern? Well, you know, your users, you know, call your API through the AWS API gateway. You know, in Kubernetes land, that could be an ingress, you know, an ingress controller, or it could be, you know, a Kong, you know, a Kong ingress, you know, something like this. And then behind that API gateway, depending on the route that you hit, you execute a Lambda function. And maybe that Lambda function needs some, you know, to store some data, so it connects to DynamoDB. Okay. So that's really, you know, typical web services pattern that you can implement in AWS. And a lot of developers gravitated to this because they needed to deploy a new API, or they needed to build a new API. And, you know, with API Gateway and DynamoDB, you have those as services, as building blocks, right? You can just take them, configure them. And then, you know, the actual processing, the actual logic, you know, that needs to happen is coded in your function. And then you submit that function to Lambda, and it takes care of, you know, the build and the scaling and the update and so on, right? So that was really the big driver, building an API. If you don't want to expose such a thing to the public internet, you can just actually call your Lambda directly, and that's what Jeremy calls an internal API. And I mention it because we actually use internal APIs, you know, quite a lot at TriggerMesh. We don't expose things through, you know, an API gateway. And Knative also has a setting when you create a service that, you know, it's basically a label, a Kubernetes label on an object that says whether you need to, you know, expose it through your API gateway or not, right? So web service, internal API. I'm not going to go through all the patterns that Jeremy has, you know, has shown, because there's a lot of information already in the deck, and I'm looking at the time. But you should have a look at it. You know, the one that I talked about with IoT as a pattern, he calls it the streamer, right? And here again, it's all fronted by an API gateway, but what you send to the API gateway is put in Kinesis, and then, you know, you can route through different streams, and then you can archive everything, you know, in your data lake, meaning S3, and then, you know, do you know, deeper archive in Redshift. So that would be the, you know, the streamer. One pattern that's very exciting for digital transformation and, you know, supporting legacy application, and also supporting your, you know, your move to the cloud and your, you know, your acceleration to the cloud, is the strangler pattern. And that's something that you see a lot. We didn't have to wait. To get serverless to talk about the strangler pattern. We talked about it in the cloud days with pure VMs also, but that pattern is definitely there with serverless. So what do you have? You have a legacy application, bottom right, fronted by an elastic load balancer, right? But then if you need to add an additional feature to your application, instead of either buying an add-on or having to code some old style monolith application, whatever, you can just add an API gateway and go straight to Lambda and leverage DynamoDB. And little by little, every time you need a new feature, you can just strangle the legacy app by developing outside. So you don't need to lift and shift. You don't need to migrate off of your legacy application. It's just that little by little, you're going to strangle that legacy app. And then one day you're going to be like, hey, you know what? We don't use it anymore. Everything is in the cloud. So that's the strangler, right? So those are quite high level. They're very AWS specific. If you look at Argo, which is in CNCF, you start to see the components, right? The abstractions, we tend to say, to be able to build that type of applications. So in Argo events, right? I'm not talking about Argo workflow or CI/CD and Flux and so on. In Argo events, you have the concept of an event source, and you have the concept of a sensor and a trigger. All right. The concept of trigger here is a little bit confusing compared to Knative. And here, it may be too technical, if for those that have never looked at those packages. But a trigger in the Argo events world is actually a workload that gets executed. So a trigger is AWS Lambda or an Argo workflow or an HTTP webhook or something like this, right? Whereas in the Knative world, a trigger is actually a binding between a certain type of event and a target or a source. So anyway, in Argo, you have this concept of where are events coming from, and then those events are detected by a sensor, and the sensor triggers the execution of a particular workload. The system is changing quite a bit from a couple months ago when 6 months ago maybe when I looked at it. Now they added an event bus based on NATs, and it's very interesting because this is starting to actually look a lot like Knative eventing, and it's also a bit sad for all of us in the community that we end up with two different projects. But you have this concept of source, this concept of bus, right, and then this concept of trigger. That's Argo. What you can do with this is really go back to the SAGA pattern. And the SAGA pattern is quite old, goes back to '87. And that's a way to basically do long-lived transactions by using multiple services. And when you look at this pattern, well, you see that you have independent services that perform actions, but then they emit events and they process events. So that's exactly serverless. That's exactly what we're doing with serverless and how we are architecting those, those serverless applications, except that those microservices from the SAGA days, are now cloud services that themselves are distributed and can scale and so on. All right. And then in TriggerMesh, we really, of course, totally embrace all of this thinking about this type of serverless applications or integration, for all your apps. And what we have is a concept of a bridge. So for us, a cloud native application, which is really an integration issue, is a bridge between an application that's the source of events and then an application that's the recipient or the target of certain events, right? So what we're trying to do is that we're bridging an application as a source and an application as a target. So when you go to the TriggerMesh console, you have to define an event source. And then at the bottom or far left, depending if you prefer it left to right or top to bottom, you define a target. The one thing that we have in addition to Argo is that in the middle we have a broker, and this broker is an abstraction on top of the messaging system that's needed, right? And that's the thing that allows us to route events and events of a certain type to the right location, right? Of course, all of this is linked by CNCF cloud events, right? So TriggerMesh bridges. And what do we do with this? Well, we end up building solutions that are ready to go. And we do integrations between, let's say, your GitLab. If you want to trigger a Lambda for processing, specific data from a commit, or doing certain things when your developers do pushes or create issues or create wiki pages, wiki pages. If you want to send all your Slack conversation to Confluent for processing, we have a solutions for this, which is a bridge. Again, Slack as a source, Confluent as a target. Customers of ours is interested in Azure Activity Logs going to Splunk. So here you see again, it's a cloud native application. It fits in the realm of log aggregation and analysis, but we need to create this application flow with a source, Azure Activity Logs, going to a target, Splunk, and in the middle, if you want, you can of course filter the logs, enrich them thanks to functions, right? So that's where you're starting to see this entire concept of meshing, services that are in the clouds, services that are on-prem, and enriching the events in the middle, maybe transforming them using, functions, right? So the benefits of all of this, minimal coupling between all the services, independent scalability, independent development of each service, ability to use best of breed. So, hybrid cloud. You want to use Google for that. And you know what? You still have your VMware on-prem, go for it, right? So that's really the benefits of starting to build with that type of mindset.
Hey, Sebastian, I lost you for a bit on that last slide. Do you want to just go over it again?
What, with the noise, the sound?
Yeah, I think Mark did as well. So if you just want to go over that.
Okay, cool.
Thanks.
Yeah, so the benefits here are really that, you have minimal coupling between all the services. You have independent scalability, so each service can scale on its own. They can be developed on their own. And then, of course, you have best of breed. And what I was saying with best of breed is that, maybe you want to pick, you're using AWS services for most of your work. But maybe you want to use BigQuery with Google, and you just pick that. And maybe you, of course, you still have some VMware infrastructure on premise, and you want to couple things with it as well, right? So you end up picking and choosing the best of breed, right? And building this serviceful application, right? So that's really the challenge at hand. So use cases, there are lots of use cases out there from HSBC, Lego, Vanguard, Nordstrom. It's true right now, they're still very AWS specific, at least the ones that we've looked at. But you'll find use cases of, HSBC is the use case of a, strangler-like pattern where they go from mainframe, they do change data capture, and then they start building, additional applications in the cloud. Nordstrom was the same thing. They had a bottleneck with their SAP application, and they bypassed it directly from from their Oracle system and started developing some functions in the cloud. So we're starting to see quite a lot of success stories of the in the serverless / integration, really cloud native type application. And I think it's very exciting to see this world where you're meshing both, right? You're meshing on-prem with cloud and making this happen with through events, and making this happen with really a good choice for users, and making good good decisions. Live demo really quick. Really quick because we'll see. So I wanted to show you a demo of okay, hopefully you can see this again. I wanted to show you a demo of interoperability between Argo and Knative, okay? Because there is a lot of misunderstanding out there. So quickly, because I don't want to lose you, I'm going to show you a little bit here what's going on, and then I do want to finish with a bit of TriggerMesh here. What I'm showing you here is a GKE cluster, so Kubernetes, and I installed Knative. It didn't take me long. It's really a couple kubectl apply, and you end up with Knative serving running. What does that give you? It gives you a function capability with scale to 0, okay? And then I also installed Argo events, right? So if I go and I check my, my pods in the Argo events namespace, you see the different controllers of Argo events that are running, all right? And then, what I did is I said, okay, fine. Let's say I'm trying to build this little application. So what do I want to do? I want to build an event source with Argo events, and then I want to build a target with Knative serving. So all of this can be, API driven. So here I have a simple manifest of a function that will be deployed by Knative serving. All right, it's called an event display. So you see a very simple manifest, and just by magic and better API design, this will scale to 0. So we check it, get KSVC. You have your function running here, display, and under the hood you have a pod. Here you see my pod that's running. All right, so that's my function, and that's going to be my target. So now if we look at Argo events, the way it looks, again, of course you need to learn the API. So that's a little bit of the, the challenge, but here you have the manifest for an event source, which is just a cron job with Argo. Every 10 seconds, it sends hello CNCF. And then what you need to do is then define a sensor, right? So here, an Argo event sensor is defined again as a manifest kind sensor, right? And it says, hey, it's going to get this type of event name, event source name, and then you send it where? That's where you define this trigger, right? And where are we sending it? Oops, sorry. Where are we sending it? We're sending it to the endpoint of this Knative function. So this is really interoperability of an Argo event source and a Knative function, all right? So Argo, every 10 seconds, is going to send hello CNCF. And sadly, before I lose you, I can show you the logs of my display function. And I have no shame to show you things that don't work, right? And because I only spent 30 minutes on this, and of course, because it's not the last version, that didn't go through. So what's happening here in my target function? I'm getting an event, but I'm getting an error. Okay, why am I getting an error? Because the Argo event sensor doesn't send me a cloud event. Okay, so that's a little bit sad because you have an Argo event which is CNCF project which doesn't emit CNCF events, right? So that's, you know, it's a bit sad. I should file an issue, but you see the error here is fail to decode message unknown encoding. That's because the event that my Knative function is receiving is not a cloud event, and the Knative function expects a cloud event. It's like, I don't know what this is, right? So I cannot decode it. So that's this demo. I'll just finish with, you know, I have to finish with a little bit of TriggerMesh, right? Just 2 minutes. And you know, we have a SaaS available for you. It's quite, you know, it's quite useful, you know, of course, to try things. And when you log into our SaaS, you're presented with this catalog, which is fast evolving because we just got our seed funding last December. So, you know, it's been it hasn't been you know, a long time. But you land and you see our catalog, and you see our catalog of cloud native integrations, right? So, for example, you want to do sentiment analysis of your Zendesk tickets. Well, you use this application flow, which for us is called a bridge. So you use this flow, which is going to have an event source detecting new Zendesk tickets being created. Then it's going to call AWS comprehend to do the sentiment analysis. And then it will come back and tag the ticket with whether it's a positive ticket or a negative ticket. And potentially, if you want to send an SMS to your manager, if the ticket is negative, you can just insert an additional target, right? You see other, you know, other integration like the Azure Activity Logs to Splunk, you know, GitLab to AWS Lambda, you name it, right? So if we look at those integrations, the way they look like, here you see, you know, the pattern that I was mentioning, an event source at the top, a broker that does the event routing, the trigger that does the binding between certain type of events and a target, and then at the end, you know, the target, which is the Zendesk target, doing the tag creation. So of course you need to fill things in, you know, and so on. Just so that you see, you know, what happens. Let's do this one. Use template. It's the very basic one. So it's just a cron job, kind of like what I was doing with Argo events, right? So we can submit that one. So what do you have? This is all backed by Kubernetes. So this bridge, okay, is represented by a Kubernetes API, a CRD, kind bridge. So this application flow, this bridge, is fully declarative, okay? And it contains all the objects that makes the flow, right? Fully declarative, you know, API driven, right? So here now, if I look at my table, so the bridge is green, right? And what this does is that there's a cron job sending, you know, a string to my Sokai application. So, you know, if we log in, as soon as the cron job is triggered every minute, we would see the cloud event on the Sokai application. Okay, I have to check in the bridge when did I say every minute. So we go back, we look at the edit. Yeah, so every minute it's going to send hello world. So okay, here we go, hello world, and that's it, right? And here you see a proper CNCF cloud event with all the attributes of the spec. It's a 1.0 cloud event. It has an ID, has a source, you know, timestamp, and the type of the event is dev knative sources ping. Right? That's it. No more time. I hope you enjoyed it. I did. And if you have any questions, please let me know. And I'll stop sharing.
Great. Thanks, Sebastian. Yeah, if you have questions, please drop them into the Q&A tab at the bottom of your screen. Okay, we've got one from Jindong. Which part is the encoding in your TriggerMesh demo that Argo didn't have?
It's the fact that the Sokai application, accepts a cloud event, and that the broker sent a cloud event, right? In Argo, the Argo sensor, it turns out, I just discovered it, the Argo sensor doesn't send a cloud event.
Is there a self-hostable solution along with software as a service for TriggerMesh?
Yes, there is. Contact us. sepgoa@triggermesh.com.
Okay, any more questions?
Looks like that's it.
Looks like that's it, yep. Well, thanks, Sebastian, for a great presentation. And we will have the slides and recording up on the CNCF webinar page later today. Thank you all for joining us, and we hope to see you at another CNCF webinar down the road. Thanks.
Thank you, everybody.